We don't talk so much about acid, so more can talk about base now. See, base na substance wey be say e go neutralize acid to form salt and water. I don give you na such example before. But wetin in na lay school, all those things for layman, person wey just dey start, just look am see anything wey you don see OH for the body aside water. If you don dey see any compound wey don dey get OH, you go know say that one na base. For acid, if you don dey see anything wey dey get H aside ammonium, water, all those things, major compound wey dey see na H dey start am in chemistry. Compound, don know say na acid be that. Then for base, you don see say na OH dey inside. OH na dey inside. Probably one metal dey, OH dey, one metal dey, OH dey. Or one metal dey, oxygen dey, one metal dey, oxygen dey. So you just know say that one na base. You can't really get this aspect where we say majority of the people they always dey confused about base and alkali. Now, bases wey dey dissolve inside water, wey be say if you put them inside water, it go ionize, it go dissolve, dissociate into their ions. That one we dey call them alkalis. So all alkalis are base, but not all base are alkali. Note that. Then a phrase that they call them for English, I mean, what do they call them? I beg, make na borrow me. So we can talk about physical properties of base. We don't talk about physical properties of acid, man, no go there again. But we can talk about physical properties of base. Base, they bitter. Notice that. Another thing is say base, they be like soap. Make you put detergent for inside water, can't they use and they touch hand like this? No think that thing with the thing. Just use your hand touch and make it be like soap. That na base with that. It is soapy, it will make your hand slippery. They turn red litmus paper blue. Don't forget say na acid they turn blue litmus paper red. So base they turn red litmus paper blue. Base, concentrated base, they corrosive, like KOH, sodium hydroxide, corrosive. And as you can't get weak acid, strong acid, now so we get strong base, weak base. Like make how they use alkali now. We can't get strong alkali, weak alkali. So for KOH, KOH is strong, NaOH is strong, but for weak, sodium hydroxide, there plenty, weak base plenty. So I'm not going to talk about uses of base. Wetin we dey use base or alkali for? Or base, we dey use them, they make soap. We dey use them, they make dyes. We dey use them, they make shaving cream. Shaving cream, we dey use the shave. And we dey use them, they make like the steak lime. We dey use them, they make cements. They call it Ca open bracket OH close the bracket 2. Another thing we say we dey use base ammonium hydroxide. We dey use them, they make detergent, manufacturing of detergent. Then there's another one where we say we dey see for inside. They say we dey see for inside is magnesium hydroxide. We dey see for inside milk. Understand? So it dey inside milk somehow. So they call them magnesia. So then we can talk about chemical properties of base. If you react them with acid, it will give you salt and water. Any alkali with ammonium chloride, it will give you ammonia gas, it will give you salt, it will give you water. I'm not going to talk about how they measure the acidity and the alkalinity of a substance or of a solution. There's something we call pH scale. Now that scale we take the measure the acidity and the alkalinity of a substance. We start from 1 to 14. The middle point now 7. So every substance wey dey 7 means say the substance is neutral. Like for water, the ionized water now 7. No be all water dey 7. Some water they say if it be acidic, some alkaline in nature. It depends on where the water dey or where you get the water from. But when we say deionized water, no ions, the water dey neutral. So such a water number 7 a day. So if na acid, it start from 1. Let's say from 1 to 6 now, 6.9. So if this acid dey concentrated, it go dey 1. The more you don't come down, they go like 4, 5, 6. The acidity don't dey drop. So it don't become weak acid. Don't forget, at the highest 9 be 1. Like all those hydrochloric acid, HNO3, all those ones they range 1. So but it don't come down. It don't come down. Like within your place where they see all those fruits, all those things. So the more they come down, the more the acid they become weak till it becomes 7, where it become neutral. So you can continue from 8. So you say you get weak base, weak. We can be using base, we can be using alkalinity. Now the same thing when we talk, and in this aspect. So if you get weak alkaline or weak base, so the more they go up, if you don't reach 14, you don't get strong alkali or strong base. So the more that 7 na be the midpoint wey they call neutral. So now wetin they call measurement. Then the aspect wey we dey call you get another aspect, the calculative aspect. You know, to tick, you know, talk, you know, different formulas they so till they get the answer. Very, very, very easy. Now, let me just talk about salt briefly. Salt now substance wey be say they form when you don't react acid and base together. Then we can get different types of salt. We get normal salt, we get double salt, complex salt, acidic salt. I think it's about 5. Normal salt, double salt, complex salt, acidic salt, and basic salt. You get everything you use salt for. Like we use cook, we use preserve, like calcium chloride. We use dry as a drying agent. Ammonium chloride they do for farming purpose. So different types of salt. Then how would they identify salt from acid? If you don't replace that hydrogen, that's replaceable hydrogen. If you don't replace it with either metal or ammonium, don't forget metal or ammonium, you don't get salt with that. Any compound, any acidic compound, if you don't replace replaceable hydrogen with either metal or ammonium, you don't get salt with that. So you can't get different type of salt. If an acidic salt, no be all the hydrogen don't they replaceable. Hydrogen still remain inside the salt. Like NaHCO3, that one is acidic salt. If na basic, now you say instead of H, OH still inside the salt. OH dey inside the salt. Double salt, you go say it dey white a bit. Then complex salt, it dey complex. So some characteristics of some salt, efflorescence. Most of substance wey be say all those substances they always get ID, they always dehydrated. But you feel no know because it go be like crystals. Take for example like blue crystals of copper. That one dehydrated. If you don't see blue crystals, that one dehydrated. So if you heat them, you go dey comot small. All those smoke so they come out no be smoke or na water. So you go come turn white. That white don't tell you say all the water of crystallization don't come out. So it will become anhydrous copper, copper 2 tetrasulfate 6. So you get different types like that. So now all these substances, if you expose them to atmosphere, you go lose all the water content. Then deliquescence, na substance wey be say if you expose them to atmosphere, you go absorb water. Efflorescence go release all the water within body. Deliquescence go absorb all the water with the atmosphere, go become solution. Then hygroscopic go absorb the water, e no go become solution. E go dey sticky, e go dey muddy.